Today we are going to learn about implementing fault-tolerant batch processing systems. We'll explore techniques for building systems that ensure reliability and continuity in critical workflows.
Welcome to our educational series on implementing fault-tolerant batch processing systems. In the world of data processing, reliability and continuity are paramount. Fault tolerance is the backbone of ensuring that our batch processing systems can withstand failures without compromising on process integrity. This segment will introduce you to the importance of fault tolerance, its impact on the reliability of systems, and how it ensures the continuity of critical workflows. We'll provide an overview of batch processing and introduce the key concepts that will be explored in detail throughout this video. Fault tolerance is a crucial concept in the realm of batch processing. It refers to the ability of a system to continue functioning correctly even in the event of certain types of failures. In batch processing, this means ensuring that data processing tasks are completed successfully, even when individual components fail. The benefits of implementing fault tolerance in batch systems are numerous, including increased reliability, enhanced data integrity, and improved system robustness. However, achieving fault tolerance is not without its challenges. It requires careful planning, robust system design, and the implementation of specific strategies and technologies. Throughout this segment, we will delve into the role of fault tolerance in batch processing, discuss the challenges faced in its implementation, and review examples of systems that successfully incorporate fault tolerance.
Batch processing systems are susceptible to a variety of failures. Understanding these common causes is the first step in designing resilient systems. Hardware failures, such as disk crashes and memory errors, can halt processing tasks. Software bugs, often hidden until they disrupt operations, are another frequent culprit. Network issues, including latency and connectivity problems, can lead to incomplete data transfers. Data corruption, whether from faulty data sources or during processing, poses significant risks to data integrity. Finally, human errors, such as misconfigurations or incorrect data entries, can trigger failures. This segment will explore these common causes of failures in batch systems, providing real-world examples and discussing how they impact system operations.
Designing fault-tolerant systems involves adhering to a set of principles that enhance the system's ability to withstand failures. Redundancy is key, providing backup components that can take over in the event of a failure. Isolation ensures that failures are contained and do not propagate through the system. Decentralization distributes processing tasks across multiple nodes, reducing the impact of a single point of failure. Graceful degradation allows a system to continue operating at reduced capacity rather than failing completely. Finally, failover strategies ensure that system functions are transferred smoothly to backup components during a failure. Each of these principles plays a critical role in designing robust fault-tolerant batch processing systems.
Retry mechanisms and checkpoints are essential components of fault-tolerant batch processing systems. Retry mechanisms handle transient failures by attempting to reprocess failed tasks. This is crucial for handling temporary network issues or resource unavailability. Checkpoints, on the other hand, save the state of a process at specific intervals, allowing the system to resume from the last successful checkpoint in case of a failure. This ensures data consistency and minimizes the loss of processing work. Implementing these techniques requires careful consideration of the types of failures to be addressed, the cost of retries, and the frequency of checkpoints. Best practices include configuring exponential backoff for retries and ensuring that checkpoints are durable and reliable. Data integrity checks are vital for maintaining the accuracy and reliability of batch processing systems. These checks ensure that data is not corrupted during processing and that it meets the required quality standards. Techniques for data validation include checksums, hash functions, and validation rules. Handling corrupted data often involves isolating and reprocessing the affected data or applying corrective actions. Ensuring data accuracy is critical for building trust in the system's outputs. Various tools and technologies are available to assist in implementing data integrity checks, including database management systems and data validation libraries. This segment will explore the importance of data integrity checks, discuss techniques for data validation, and highlight tools that can aid in their implementation.
Distributed systems offer numerous benefits for building fault-tolerant batch processing systems. They enhance scalability by distributing processing tasks across multiple nodes, allowing the system to handle increased workloads without degradation. Resilience is achieved by ensuring that node failures do not disrupt the entire system. Techniques such as data replication ensure that copies of data are available across different nodes, providing redundancy and improving fault tolerance. Handling node failures often involves redistributing tasks to other nodes and ensuring that data consistency is maintained. Several distributed processing tools, such as Apache Hadoop and Apache Spark, are available to assist in implementing these techniques. This segment will explore the benefits of distributed systems, discuss strategies for handling node failures, and highlight tools that can enhance system resilience. Effective monitoring and alerting are critical components of fault-tolerant batch processing systems. Monitoring involves tracking system performance and identifying potential issues before they escalate into failures. Real-time failure detection allows administrators to respond quickly to problems, minimizing the impact on system operations. Setting up alerts ensures that the right personnel are notified promptly when issues arise. Important metrics to monitor include system load, processing times, and error rates. Logs provide valuable insights into system behavior and can aid in diagnosing problems. Several tools are available for monitoring and alerting, including Prometheus, Grafana, and ELK Stack. This segment will discuss the importance of monitoring, outline strategies for setting up alerts, and highlight tools that can enhance system monitoring and alerting capabilities. Evaluating fault-tolerant technologies and tools is a crucial step in building robust batch processing systems. This involves assessing system requirements, such as processing capacity, data volume, and failure tolerance levels. Comparing available technologies and tools allows organizations to select solutions that best meet their needs. It's important to consider factors such as ease of integration with existing systems, scalability, and support for desired features. A cost-benefit analysis helps determine the most cost-effective solutions that provide the maximum resilience and reliability. This segment will guide you through the process of evaluating fault-tolerant technologies and tools, providing insights into selecting appropriate solutions and integrating them into your systems. As we conclude our exploration of implementing fault-tolerant batch processing systems, let's recap the key concepts we've covered. Fault tolerance is essential for ensuring reliability and continuity in critical workflows. Implementing fault-tolerant systems involves understanding common causes of failures, applying design principles, and leveraging technologies such as retry mechanisms, checkpoints, and distributed systems. Continuous improvement is vital, as systems must adapt to changing requirements and evolving threats. We encourage you to explore further resources to deepen your understanding and enhance your skills in building fault-tolerant systems. Thank you for joining us on this educational journey.